Good morning, everyone. Hope all is well. Hope everyone's doing all right. Just waiting on a few people to get connected and then we'll get rolling.
Good morning.
Good morning, good morning. All right, looks like everybody's in. So once again, good morning. Hope everybody's doing all right. We are about to, let's see, where did we leave off last class? That was 2-1. So we're looking to do, nope. Was that 2-1? Checking to make sure. No, we did 2-2 last class. Yes. Okay, so we're looking to get started in 2-3 today. Any general questions or concerns, comments before we get rolling? Let me answer this real quick. All right, so let's go ahead and get rolling. All right, so 2.3 linear functions and slope. Okay. All right, yep, most definitely we can take care of that before we leave. So slope is going to be represented by M. So we don't use S for slope, we use M for slope. S is used in other places like for speed, and I think it's one other thing S is used for, but anyway, we'll be using M for slope. The way we calculate it is by y2 minus y1 over x2 minus x1, or you could actually reverse and use y1 minus y2 over x1 minus x2. You just have to be consistent in how you calculate it. So if you're going to use y2 first on top, make sure you use x2 first down bottom, or if you use y1 first on top, make sure you use x1 first down bottom. Also, we'll be using the relationship for the slope as Riles over run, and that we will use in order to graph. Whenever we're trying to graph, we will use Riles over run. All right. So x1, y1 comes from any 2 points on the line. You know, x1 will be and y1 will be considered point 1. x2, y2 will be considered point 2. So any 2 points on your line will enable you to calculate the slope. So the slope is just going to be a numerical representation and identification or direction of the incline of your line, you know, or the incline of any slant. So just like we talk about the slope of a mountain, the slope of a ramp, or the slope of a roof. So we put numerical value to that slant. All right. So first thing we want to emphasize is calculating the slope using 2 points, 2 points that are given, and those 2 points would be on the same line. So we have -3, -1, and -2, 4, and we want to find the slope of the line that's passing through those 2 points. So the first thing we want to do is to establish which point you're calling point 1, which one you're calling point 2. It doesn't matter. Just that you just need to establish which one you want to call x1, y1, which one you call x2, y2. Normally, the first point I see is the one I call x1, y1. Second point is x2, y2.
Sorry I'm late, sir.
Oh, that's okay. It's not a problem. Yeah, you haven't missed much. We're just calculating the slope.
Gotcha.
So we're going to do it both ways. Remember I mentioned you could do y2 minus y1 over x2 minus x1 or y1 minus y2 over x1 minus x2. So we're going to do it both ways just so to show you that either way you'll come up with the same answer. But after that, of course, we only do it one way because only one way matters as long as you do it correctly. So looking at the first one right here, y2 minus y1 over x2 minus x1. So our y2 is 4, y1 is -1. So that's 4 minus -1. Make sure you don't lose a negative. There's a minus sign in the formula, and we're substituting in -1 for y1. And then x2 is -2, x1 is -3. And so this would be the substitution right here. Right. In both cases, top and bottom, we have a negative to a negative, which is positive. Then we have 4 plus 1 on top, -2 plus 3 on bottom. That's 5 over 1, which is just 5. Any questions on that? Any questions? All right. So here, same problem, just decided, like I mentioned before, y1 minus y2 over x1 minus x2. So we're taking the same numbers, doing our substitutions, but in reverse. So now we have y1 minus y2 on top. That's -1 minus 4. And on bottom, -3 minus -2. Simplifying, that ends up being -5 over -1, which is +5. So either way, we'll get +5. We just have to be consistent with our substitution and calculation, being correct in our substitution and calculations. All right. Questions before we do another one? All right, next one, -3, 4, and 2, -2. Once again, establish which point you're calling point 1 and which one you're going to call point 2. From there, we use our formula to plug in our values. So that'll be -2 minus 4. Then on bottom, 2 minus -3. And that will be -6 over 5 as our slope. All right, any problems, any problems? All right, so we have 4 basic behaviors of our slopes. Following our lines from left to right. If our line is red and the green is just you following that line. Once again, we're going from left to right. If your line is going up, then it is positive. Your slope is positive. If it's going down, your slope is negative. If your line is horizontal, your slope is 0. If your line is vertical, your slope is undefined. Any questions? All right. Scroll up, everybody good? All right, now we're looking at graphing using our slopes. So remember I mentioned that last relationship, or the last part of the relationship when it came to our slopes was rise over run. The rise is going to represent your up or down. Your run is left or right. All right. So don't forget we had y2 minus y1 on top. That's your change in y. That's why this is up and down. Then on the bottom we had x2 minus x1, which is your change in x. That's why the bottom has right or left. Now, what would dictate whether we move up or down versus right or left will be whether our number is positive or negative. We have positive moves, which are up and right, and then we have negative moves, which are down and left. So if our top number is positive, I will go up, but if my top number is negative, I will go down. If my bottom number is positive, I will go right. Or if my bottom number is left, negative, then I will go left. All right, so just examples on how that works. Put some numbers on it. So if I have 2 over 3 as my slope, that just means both of them are positive. That's positive 2 over positive 3. That's up 2, because that's a positive move, and then right 3, positive move as well. On bottom, not on bottom, but the next example, negative 10 over positive 7. Now that negative cannot be assigned to both top and bottom. And so you would give it to either the top or the bottom. You know, negative over negative is positive, so that's why that wouldn't be the case. So normally I'll say just give the negative to the top number always, and you always be good. But it's up to you if you want to give the negative to the bottom as well. You just can't give it to the both. So if I have negative 10 sevens, if I decide to allow the negative to be with the 10, so that's a negative 10 over a positive 7, that means I will go down 10, right 7. Or I can do positive 10 over negative 7, so that means I will go up 10, left 7. Both of those will still give us the same line. If you take a look right over here, let's say if my point is right here, if I go down 10 and left 7, that will put me here. Or if I were to go up 10 and left 7, that will put me over here. So either way, it will still give me the same line, just that you will take, different directions on how to get there. All right, any questions? Very good. All right, so your slope-intercept forms is the next thing. That's going to help us to graph as well. When you solved your equation for y, that's why I have my y arrow pointing at the y. When you solve your equation for y and simplify it as much as possible, whatever's sitting in front of x is your slope, and then your other number is your y-intercept. That's what we have right here. Y is equal to 2/3 x minus 1. 2/3 is in front of x or attached to the x, so that's your slope. And then that negative 1 is your y-intercept. And the same thing with this next example down here. Y equal to negative 4x plus 3. The negative 4 is your slope, and then the y-intercept is 3. All right. Any problems? All right, so let's look at using this information to graph. First thing we want to do is, if we have our equation, solve for y, and I can pick out what my slope is and what my y-intercept is. And I'll put this stuff back, but I just want to start here. So my slope is 2/3, y-intercept is -1. So that's where you start. Now that's a positive 2/3, so that's a positive 2 over a positive 3. So I have all positive moves. So that means I will go up 2, right 3. And then my y-intercept. For all y-intercepts, x is always 0 when you want to plot that point, or if you want to establish that it is a point. X is always 0 for all y-intercepts. So if you look in the green, those are our directions as far as using slopes in order to help us to graph. Notice the first thing we're going to do is graph the y-intercept first. You always graph your y-intercept first. Then we're going to use the slope to generate another point from the y-intercept. So we're not going to go to the origin with the slope. You go to your y-intercept with the slope and then generate another point. So right here is the y-intercept. That's 0, -1. That's the first thing you graph. And then from that point, I will go up to right 3, which will put me right here. All right, any problems with that before we go any further? So of course, then you connect your dots, and that will be your line. All right, questions before we do another one? All right, here, y equal to -5x plus 4. So what's in front of x is our slope, so that's -5. And then the other number will be our y-intercept, which is 4. Now -5 as a fraction is -5 over 1. And that's a -5 over a positive 1. So I'll go down 5, right 1. And then once again, as my y-intercept, the order pair will be 0, 4. The x is always going to be 0 for the y-intercept. Any questions? So once again, you graph your y-intercept first. That's right here, 0, 4. You go nowhere for x, but then you just go up 4. And then from your y-intercept, you go down 5. And then right 1, which will put me right here. And connect your points. All right. Any questions on the graphing process with your slopes? All right. Scroll up. Everybody okay? All right. Next formula is your point slope formula. Y minus y1 equal to m times x minus x1. So we have m, which is our slope, and then x1, y1 is any point on the line. So if you know any point on your line and the slope, you can create the equation for it. All right, first example using this, we have write an equation of the line that passes through -1, 3 with a slope of 4. All right, so here we just extracted the information that it gave us from the table. Your slope is 4, and the point is going to be x1, y1. Here's the formula that we will use. Notice that we're going to plug in for y1, m, and x1. Y and x will still be a part of your equation. And then we substitute accordingly right here. So we plugging in 3 for y1, 4 for m, and then -1 for x1. All right, so that will leave us with y minus 3 equal to 4x plus 4 after we do our distribution. Then we're going to go ahead and simplify all the way by adding 3 to both sides. Y is equal to 4x plus 7. Any problems? Any problems? All right, let's scroll up. Okay, next one, write the equation of the line that passes through 8, 5 with a slope of -1/4. So same scenario that we had in the previous example. They give us our slope and our point. So we'll plug those in accordingly. So 5 for y1. Get this out of here. Then we have 1/4 for m, and then 8 for x1. Any problems with the substitution? All right, so next we're going to distribute. So that's -1/4 times x, and then -1/4 times -8. And so right here, I just went ahead and did the work, just making sure we're okay with the multiplication of our fractions. So it's 1/4 times 8, multiply across. That'll be 8 over 4, which would just give us 2. Of course, negative turns positive, but that's how we got this 2 right here. All right. Then to finish it off, add 5 to both sides. 5's cancel on the left. And this will be our result. 5 plus 2 is 7. Any questions? All right. Got it good before we, I think 2.4 piggybacks off of, yep. So everybody good with this before we look at 2.4? All right. 2.4, more slopes. First, they first start off with parallel lines. Parallel lines are lines that do not cross or touch. And the key to that we want to point out and hold on to is the fact that your slopes are going to be the same. If the lines are parallel, your slopes will be the same. You know, that means they have the same slant. Perpendicular lines are lines that intersect at a 90-degree angle, or when they intersect, they create a 90-degree angle. And the slopes of two lines that are perpendicular are negative reciprocals of each other. So we'll talk about what that means in a second, give you a chance to copy that down. All right, so what does it mean to be a negative reciprocal? All right, so here, this is just being a reciprocal. If you're talking about a fraction and it's reciprocal, that's just a fraction being flipped. So if I have 3/4, flip 3/4, that's 4/3, that's the reciprocal. They're reciprocals of each other. Negative 10 over 7, 7 over negative 7 over 10. You don't change the sign. All you do is flip the fraction. That's a reciprocal. And same thing with 5 and 1 over 5. Now, negative reciprocals, another word for opposite is negative in mathematics. So if you're talking about negative reciprocals, which is what we have over here, you have to flip the fraction and change the sign. Okay, so this is what perpendicular lines have. You flip the fraction and you change the sign. So 3/4, if you're talking about a fraction, not a fraction, if you're talking about an equation that has a slope of 3/4, a line that's perpendicular to that is negative 4/3. Line that would be perpendicular to negative 10/7 would be positive 7/10. And then for 5, it would be negative 1/5. Any questions on that before we go any further?
I have a question.
Mm-hmm.
So only the top, I'm seeing that only the top numbers are negative, so you don't change the sign on any of the bottoms ever, or is it just for like these particular numbers?
Let me see, I'm trying to find a place to write. This is what I do. Let me take it over here. So when you're talking about fractions, let's say if I have negative 5 over 2, that's the same thing as negative 5 over 2. Same thing as 5 over negative 2. All of those mean the same thing. It's just
Okay.
that these are the ones that are used. This is never used. So if I have a negative down bottom, as far as mathematics is concerned, the best way to write that is to either bring it out front or to bring it up top.
Okay.
Yeah. So like I said, just make sure everybody's straight that all three of these mean the exact same thing, but it's just notation. And mathematics will want your final answer with the fraction, not the fraction, the negative either sitting out front, which is this one, or the negative being up top. But like I said, if your calculations came down and your answer was like this, that's still the same thing. It's just that they wouldn't leave the negative down here. Hopefully that answers your question. Uh, all right. Anything
Yes, I
else?
get.
Okay, cool, cool. All right. So let's make sure we further drive this point home as far as the difference between your parallel lines and perpendicular lines. All right. So in this little chart that I made in red, we have our original slope. So let's say we have a line that has a slope of 8/3. If I want a line that's parallel to it, it's going to have the slope of 8/3. All right. Same thing here. If I have a line that's has a slope of negative 9/11, if I want a line that's parallel to it, it would have to have the slope of negative 9/11. All right. Now, if I want a line that's perpendicular to 8/3, then I would need a line that has a slope of negative 3/8. All right, you have to flip the fraction, use the opposite sign. And then the same thing with negative 9/11. If I want a line that's perpendicular to that, I flip the fraction, use the opposite sign, and that will be positive 11/9. All right, any questions on those relationships? All right, can I scroll up? All right, so first example, using this information. Want to write the equation of the line passing through the point negative 3, 1, and is parallel to the line y equal to 2x plus 1. So we have a point that this line passes through, but we need to establish what our slope will be in order for us to create the equation, in order for us to be able to write the equation that fits these conditions. So first thing we'll do is look at the equation that they give us, y equal to 2x plus 1, and establish what is the slope for that line, and it's 2. Remember, if your equation is solved for y, whatever's sitting in front of x will be your slope. So our slope for this line that they gave us, or this equation that they gave us, is 2. Now, going back to what we just finished referencing, what is the slope of a line that's parallel to it? That will be 2 as well. All right. Remember, if it's parallel, it's going to have the same slope, have the same slant, same incline. Now that we've established what our slope will be, and we had our point because that was given to us, now we can use our point slope formula, y minus y1 equal to m times x minus x1, and plug in our values. All right, so before I scroll up, just want to make sure everybody's done copying. All right, so now we plug in, y1 is 1, 2 is m, and x1 is negative 3. Make sure you don't lose that negative. That's going to be a positive. That's going to be x plus 3 in the parentheses. Distribute 2, that'll be 2x plus 6. And then add 1 to both sides in order to get that y by itself. Y is equal to 2x plus 7. Any questions? All right, and I scroll up. All right, next one, write the equation of the line passing through 3, -5, and this time we're looking at being perpendicular to the equation x plus 4y minus 8 equal to 0. And then this time it told us to express in general form, so we'll talk about that when we get there. All right, so we have this equation, x plus 4y minus 8 equal to 0. And we need to know what is the slope for this line before we can establish what the slope for the line that we're trying to find will be. So the first thing we have to do is solve this equation for y. Remember, when it's solved for y, we go back here. When your equation is solved for y, then we can easily just pick out what the slope is. So we're going to take that equation and solve it for y. First thing you'll do, subtract x from both sides and add 8 to both sides because we want to get y by itself. So we're taking everything else to the other side. Then divide by 4. And don't forget that that 4 has to go to each term on the other side. And that gives us this over here once we simplify as much as possible. Y equal to -1/4 x plus 2. Now, once again, just make sure we hold true. Don't get too happy. This is the equation that we originally had. This is the same equation right here. X plus 4y minus 8 equal to 0. It's just in another form. We put it in this form. We solve our equation for y so we can pick out the slope of this line. It does not mean it's going to be the slope of the line that we're going to create. That's just the slope of this line that it gave us. So that -1/4 is our slope. That's what's sitting in front of x. That's our original slope. Any problems with that before we go to the next step? All right. So now, remember, we want the slope of a line that's perpendicular to this line. So that means you're going to flip the fraction and use the opposite sign. And so that will be +4. Any problems? All right. Well, we have our slope now and the point. They gave us that point that the line runs through. It has a slope of 4. And then we go ahead and use y minus y1 equal to m times x minus x1 and plug in our values accordingly. So it's -5 for y1, 4 for m, and then 3 for x1. So negative for negative turns positive, so it's y plus 5. Then distribute 4, 4x minus 12. Then to simplify it as much as possible, we will subtract 5 from both sides. And that'll give us y equal to 4x minus 17. Now we're almost finished, but they ask us to put it in general form. But just want to make sure everybody's okay as far as copying, and they are up to this point before we go there. All right. So general form is this right here. AX plus BY plus C equal to 0. So basically they just want you to put everything on one side of the equation. So we already have our equation as y equal to 4x minus 17. So if we just minus y from both sides, that will be our equation in general form. Any questions? Everybody good? Everybody straight? Can I scroll up? All right, check something out. Yeah, okay. Probably need to notate. Well, it'd be fine. All right, so that's where we'll stop today. There's 2 sections. So we did 2-3 and 2-4. That's enough for today. Any questions? Any questions, concerns, comments before we wrap it up for today? Anybody have anything? Anybody get stuck on? I know somebody mentioned something about a test, but I don't know if that's like an individual question or not. I know she may wait until afterwards. So everybody's good. Everybody's straight. No general questions. All right. Somebody said something in the chat. Just want to make sure. I will do my best to get to them. I know I have a couple meetings today, so it's just about if I get the time. If I get the time, I most definitely will post them. So I'll try to shoot them out for you today. All right. So if you guys are good, then I'm good. Take note that we're moving. So make sure you guys are, keeping up with your assignments in my math lab. You got that test that's out there as well from chapter 1. So this is 2-4. We halfway through. So, next thing you know, we'll be done with chapter 2. So don't take these assignments too lightly. Want to make sure you're progressively doing them as we progress throughout the course. All right. So you guys have a great weekend. Be safe. I know I have to stay on for a few people afterwards, but outside of that, you guys take care.
Thank you, Professor. Have a good
Thank
weekend.
you.
Have a good day, Professor.
Thanks. You do the
Have a
same.
good weekend.
Take care.
Thank you, Professor. Enjoy your weekend.
Thanks. You do the same.
Thank you. Bye.
All right. Take care. Go ahead and stop the recording.